welcome back to my channel. So today I am discussing about a D ALEMBERT'S principle. So in this principle, before going to this principle, I already discussed about the principle of a virtual work. So in that I arrived a expression that is Fi A into delta Ri is equal to 0. Summation is from I equals to 1 to n. This is the expression for a principle of virtual work. So today in this video, I'm going to discussing about a DLMS principle, which is a very important for your point of exam. This is very important. So here what we are doing, we are considering a Newton's second law of motion, the force acting on the ith particle. So it is a in general equation or in general derivation. So for that reason we are taking a I as a in general quantity, that is a ith particle is given by, so Fi is equals to dpi upon dt is equals to pi dot. So we can write this d by dt in a dot. This is the very important thing. So we know that from the Newton's law, F is equals to dp by dt. Okay, Newton's second law. So this d by dt can be written as pi dot. So moving further, this can be written as a Fi minus pi dot is equal to 0. So what we are considering? We are considering that Fi minus pi. Fi minus pi is equals to 0, and that is I equals to 1, 2, so on up to n. So here we are taking a I value as 1, 2, up to n value. Okay. So here what we are considering, Fi is the actual force. Okay. Pi dot is a reversed force. Pi dot is a reverse effective force. Okay. So pi, it is not a momentum, linear momentum. It is also one of the force which is in the reversed effective force. Okay. Fi is the actual force. Pi dot is a reverse effective force. I think it is clear. Moving further, summation of I equals to 1 to n Fi minus pi dot into delta Ri is equals to 0. Because I earlierly told that we are earlier defined virtual work. So we have to use this equation. So in that I told that Fi, here in this Fi we are substituting a Fi minus pi, because in D ALEMBERT'S principle we are considering a force Fi minus pi, that is a actual force minus a reversed effective force. We are subtracting, or we are taking a difference of these two and putting in this equation. I hope you clear this. Okay, moving further, Fi is equals to Fi a plus Fi. So this Fi I can write it as Fi a plus Fi. So what happens if we take like that? Just substitute over here. So what happened? Fi a, in place of Fi I'm going to write it as a Fi a minus pi dot as it is into delta Ri plus summation of I equals to 1 to n Fi, small fi, this quantity I am taking, Fi into delta Ri is equals to 0. This is from the virtual work, principle of virtual work. Constraints is 0. So let us consider this entire virtual work of constraints. So if you want a constraint video, I will upload that. So virtual work of constraints is 0. So what happened? This summation of I equals to n Fi delta Ri becomes 0. Moving further, so if this quantity is equal to 0, then remaining thing is Fi a minus pi dot into delta Ri is equals to 0. This is our D ALEMBERT'S expression. I hope this entire derivation is clear to you. Subscribe and like my video.